Using this VI, we'll learn how we can use the filter function in LabVIEW. In the ideal case, we'll use a DAC assistant for our input signal, but here we'll use a simulate signal function. We can use different types of wave function, but we'll use for this case the sine wave, and we have the option to change the frequency, the amplitude, the phase, and the offset. We'll use the default function with a frequency of 10, and then we will use three different filter function. The first one is the low pass filter. As we can see, the cutoff frequency is set as 1500 Hz. It will allow all the frequency that is below this cutoff frequency. The next one is the bandpass filter, and we've set the low cutoff frequency as 1500 Hz and the high cutoff frequency as 3000 Hz. This will allow the frequency, the waveform that within this frequency range. And the third one is the high pass filter, and we set up the cutoff frequency as 3000 Hz. So it will allow the waveform that has the frequency above 3000 Hz. And then we have this spectral measurements, and we already know how to use this. So if we input the waveform, this will convert and then give us the amplitude and the frequency using the fast Fourier transformation analysis. So now if we run this VI, we'll see how this waveform. So if we look at the top left one, the low pass result, and change the frequency to 100 Hz, we can see at the bottom the frequency is like showing somewhere around 100. And then if we change that to 500, we'll see that exactly 500 Hz, and we see the waveform in the top left corner as well. And there is no, because we have set the filter, the band pass and high pass based on the range, will not see any waveform or the frequency of the waveform. Now if we change the frequency to 1000 Hz, we see we have this 1K, so that's right on 1000 Hz, the low pass frequency from the filter. But we'll see in the band pass and the high pass, we have some sort of noise. When we change the frequency to 1400, see the frequency in the band pass, so that's very close to the range that we have set, in this case the 1500. So we'll see a significant amplitude of the frequency, but still the amplitude of the frequency in low pass is the significant one, and we'll treat the other one, the frequency at the band pass, as a noise in the system. When the range are very close, we'll see this happens because of the effect of the frequency. We'll see the noise will show up in the other ranges. If we change the frequency to 1600, we'll see that now shifted from the low pass to the band pass. Now we see the peak is larger in the band pass frequency, and it's much smaller in the high pass and smaller in the low pass frequency. Now change that to 2250, and we'll see now it's significantly lower in the low pass because that's kind of far away from this cutoff frequency set of 1500. And now we can see a significant increase in the noise in the high pass because that's now closer to that high pass frequency range of 3000 Hz. But the significant one still inside that band pass because that's within the range of that filter. Now when we change the frequency to 2900, we'll see the noise in the low pass that's much smaller now because that's now more close to that high pass and that within the range of the band pass. So we'll see a significant increase in the noise in the high pass filter, but still the higher signal is inside this band pass frequency range. And now if we change the frequency to 3100 Hz, we'll see how it shifted to that high pass frequency range. So in band pass now it's smaller, and in high pass now it's higher than the band pass, and we can treat the band pass, the neighboring frequency, as the noise in the system. Now change that frequency to 4000. Now we can see that's much smaller in low pass and band pass, and that's significantly higher in high pass, because that's now very uh, high compared to the low pass and band pass, but it's high enough for the high pass filter. We can use the slide bar to change the frequency and see how it shifts toward the low pass frequency based on the waveform frequency, and we can go around 4000 again and see how it shifted from the low pass frequency to the high pass frequency.